In the previous video, I talked about uh, how to use the Keynesian consumption function just with consumer spending. But because um, because consumption um, is just one aspect of the GDP, we also need to include investment spending and government spending. So the textbook I use splits investment spending and government spending into parts of two chapters, so they're split off from each other. But in terms of math, it's actually more helpful to talk about these two together just right now. So far we learned that C equals to Y, right? So let me go back here. So C equals to Y, and that's the function that is equilibrium for the for GDP. However, what we want to do is add in all sectors of the GDP. In this model, we're not going to talk about imports and exports because it makes everything really complicated. So we just assume that there's no imports or exports in this economy. And what we get instead of just C equals Y, we get C plus I plus G equals Y. And you're saying, oh yeah, this is going to add in like so many more variables, make it so much more complicated. But the good news is we're going to hold I and G constant. And so whenever you give it a consumption function, yeah, sure, you're going to have a variable, um, like you're still going to have an equation that'll model the consumer spending as it changes with increasing disposable income. But investment spending and government spending, they don't depend on disposable income because disposable income is not something that governments or businesses have to worry about. That's a thing that you worry about at home. So uh, so really now what we're going to talk about is just incorporating the math into it now. So what you really don't need now anymore, um, or I should say, um, now what we're going to do is we're going to just add in a few more things um, to uh, make our consumption function knowledge complete. Um, so, so C plus I plus G equals to Y. And when you're going to solve these functions, I is going to be a certain amount. So let's say it's 300 billion. And G is going to be, let's say 250 billion, right? And then you're given C still as an equation. So it's still variable. And so typically it'll be something like, I don't know, let's say autonomous consumption is 100 billion and our marginal propensity to consume is 0.75, and then this Y disposable is still here. So what we'll do is we will plug the right side of each of these equations into this mega equation, C plus I plus G equals Y. And what we'll do is we will now split Y sub D into two components, Y minus T. So what this means is we're going to replace Y sub D, disposable income, with what it really means. Disposable income, if you might remember, it is the total income after taxes have been taken out. So taxes should not be part of your disposable income because if they've been taxed, then you can't spend it. So taxes are another important part, and they will be given to you. Okay. So if we plug, let's say taxes in total are 150 million. So if you plug all this into the consumption function, right, you'll get that y equals to 100 billion plus 0.75 y minus t, which is 150, and let me make that into a minus sign, and then we'll add in government spending of 250 and investment spending of 300. Sorry for going out of order, but you get the point. If we take the distributive property over here, right, then we will get 0.75 multiplied by negative 150, and that's a certain value. So the trick here is this is the only variable, and the reason why we are plugging all these into this equation is because now you've already learned how disposable income changes by consumption. So that's not what we're going to talk about here anymore. That process is the same no matter if investment or government spending is included with the entire GDP. What we really are going to be fixing here is, before we just talked about, oh yeah, C equals Y, and that's a simplified version that we're going to change now, okay? So when we're solving for equilibrium, we can't just say C equals Y anymore. We have to include I and G. The good news is these are all held constant, right? In terms of just a certain scenario. And also taxes are going to be constant. Just remember to multiply the marginal propensity to consume onto it because of the distributive property. But that being said, Y, the GDP, is still going to be the only variable here. And over here is another Y, right? And so you'll subtract them from both sides, and you'll get over here, eventually you get 0.25 Y equals 100 minus 0.75 times 150, yada, 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 and on and on and on. And so that really doesn't matter, but the really thing that matters here is that you'll be able to get Y, and that's the equilibrium GDP that you're trying to get. So now what you want to do is influence the aggregate demand, right? Sorry, let me clarify. Y is going to be your real GDP, but it's not the natural real GDP. And the natural real GDP is what you're looking to get to in order to make the economy into long-run equilibrium, right? So you'll be given what that natural real GDP is, and you'll compare this Y value you got over here to that. If this Y value is less than, then you have a recessionary gap, and then that's what you need to fix that, right? So how do you fix it? Well, you have to stimulate spending. How do you stimulate spending? There are several ways to do so. But the primary way to do so is to increase government spending. Basically what we want to do now is analyze, if you increase or decrease investment spending or government spending, how's that going to affect the GDP? And so what we'll do is we'll introduce this concept of an autonomous spending multiplier into here. And so for each sector, it's going to be delta Y, right, which is the change in total output or change in GDP, divided by the respective sector. So it'll be either I, but for government, it'll be delta G, or sorry, they're not equal, but it's the analogs of it. And another way to express this is by using the marginal propensity to save. So marginal propensity to consume, right? It's equal to 1 minus marginal propensity to save, because whatever you don't consume, you save. And so if you add them up, they always equal to 1, because that's like just the slope of 1 instead of less than 1, and that's basically this line over here. And so whatever you don't consume, you'd have to spend. Or sorry, whatever you don't consume, you have to save. And so this marginal propensity to save is pretty important, because with it you can get what's called a spending multiplier. And the spending multiplier basically says, okay, if you increase investment or decrease investment, if you change investment, or if you change government spending, or if you change taxes even, taxes under C, in a certain way, then how's this going to create a ripple effect on the economy? And so the trick here is, it's not like a 1-to-1 ratio. It's not like, oh yeah, if you add in $100 billion to government spending, that'll increase the GDP by $100 billion. No, it doesn't work that way, because it trickles down. And so you have to account for this by calculating the autonomous spending multiplier. Basically, we're using the MPS here, so it basically means, whatever isn't saved is it's going to be consumed, and that's going to trickle down. So the MPS is basically going to be used in this equation to provide the magnitude of the change in the spending multiplier. And so problems will ask you to basically solve, like, okay, what if I increased taxes by this amount? What if I increased government spending by this amount, and yeah. So actually, first, what I can say for investments is that, yeah, you can apply this concept to investments, but you're not going to change investments by the government, like by fiscal policy. So really, we can use the same technique for investments, but only to measure, like, okay, how much is investments going to be volatile and affect aggregate demand changes. It's kind of like you're trying to do something, but you have to also account for something else you can't control that affects the final result. So we're not going to talk about that much, but the government spending and taxes, which is nestled in consumer spending, we are going to talk about now. So the autonomous spending multiplier for government spending, it's the change of GDP over the change in government spending. It's also equal to 1 over the MPS. And so whenever you find out this autonomous spending multiplier is equal to, and if you want to, let's say, if we have a recessionary gap, then this GDP Y we calculate, that it needs to be like increased, right? So if we increase it, increase the GDP, we want to find out, like, okay, how much do we need to spend from the government side in order to get this increase in the entire GDP, and that's calculated by the autonomous spending multiplier. So the trick here is actually the government only needs to spend a certain amount in order to get a magnified amount of GDP changes. Okay, and so let's say that the natural GDP is equal to $3,500 billion, and the current GDP is only $3,250 billion, right? So that means our delta y, what we need to do in order to get from here to here, is we need to add $250 billion into the GDP. And to do that, let's say the marginal propensity to save is 0.1, right? So this equals 10, right? So the ASM, autonomous spending multiplier, is 10. So that means, actually, whatever we spend from the government sector, it'll increase GDP by 10 times. Okay, so which means if we plug this into our equation, 10 equals 250 divided by delta G. And delta G is clearly 25 if you do the math. So you only need to add in $25 billion in order to get the economy to stimulate by $250 billion worth of GDP. Now for taxes, it's a little bit different because it's nestled within the consumption function. It's not the autonomous spending multiplier we have to use. We have to take into account the MPC as well. And so the tax multiplier is actually going to end up being, it's delta y over delta t, but you can get it also by negative MPC, marginal propensity to consume, over marginal propensity to save. And so it's negative because the more taxes you charge, it's going to be worse off for the economy. So it's kind of an inverse effect, right? But basically, yeah, you apply the same principles here. If the natural GDP is 3,500, and right now the current GDP is 3,250, right? And then how much of a change will we need in taxes? Well, let's say we stick with that 0.1 system, right? So it'll be 0.1 marginal propensity to save, and then marginal propensity to consume is equal to 1 minus marginal propensity to save, so it'll have to be 0.9. This is equal to negative 9. This is our tax multiplier. Okay. And so what we'll do is we have a delta y of 250, because that's how much we need to add to our GDP in order to get it to the natural GDP level, in order to get out of that recession. And so we plug it into our equation. We get 250 over delta t equals negative 9. And so if we do the math over here, 250 over negative 9 is equal to like negative 27.777. That means you need to decrease taxes by negative 27.7 billion. And so hopefully this gives you a nice overview of how to calculate all of the Keynesian consumption function, and basically how to solve the problems behind it. And hopefully now you know that this consumption function, we're doing this all because we want to find out how to increase aggregate demand, right? How we want our aggregate demand to shift to the right in order for our long run aggregate supply, which is this vertical line here, to go from a recessionary gap to no gap, to long run equilibrium. Okay, so this is the entire purpose of why we're doing this. We can do this either by taxes, decreasing taxes, or increasing government spending, and these are parts of the GDP. So we have to use the spending multiplier in order to accurately influence the GDP, and therefore that's part of the aggregate demand, right? So hopefully this helped. And just keep on practicing this, and you should be able to understand the function better.